All right, let's get into it. We hear all the time about how AI is getting smarter, right? But maybe, just maybe, we're thinking about this the wrong way. What if the next giant leap isn't about making one single AI smarter, but about creating a social network for AIs so they can all work together? That's the huge idea we're going to unpack today.
So right now, we've got these incredibly powerful AI agents. You can think of them as these hyper-specialized digital workers. One can manage inventory, another can book flights, a third can analyze market data, all by themselves. They're brilliant, for sure, but they're also working alone. It's kind of like having the world's best experts, but they're all locked in separate rooms, unable to talk to each other.
And that is the big question, isn't it? What happens when these specialized agents can actually find each other, hand off tasks, and team up on goals that are way too complex for any single one of them to handle alone? I mean, how do you even get them to speak the same language?
And that's where something called the Agent2Agent protocol, or A2A for short, comes into play. It's this really cool framework designed to be the universal translator, the standard handshake protocol for a future where AIs collaborate.
Now, the beauty of A2A is that it's not some new crazy complex AI. No, it's basically just a rulebook, a common language that lets all these different AIs built by different people on different platforms work together like they're on the same team. It's like creating a global standard for how businesses communicate, but for AI.
Okay, so that's the big idea. But how does it actually work, in the real world? Well, the best way to get it is to just follow a simple task from start to finish. Let's trace an order and see how this whole A to A thing works in action.
At its heart, A2A uses a model you're probably already familiar with, even if you don't know it, the client-server model. It's super simple. One agent, we'll call it the client, has a problem it needs to solve. It sends a request to another agent, the server, which has the skills to get the job done. It's just a clean, simple way to delegate work.
So let's make this super concrete. Our client is CustomerBot. Its main job is to handle questions from customers. Our server is OrderBot, and it's a specialist in one thing, inventory and orders. So CustomerBot needs to check if an item is in stock. A perfect job to hand off to OrderBot.
Okay, but hold on. This leads to a huge question, right? In a world with maybe millions of these agents, how on earth does CustomerBot find OrderBot? How does it even know it exists, let alone that its specialty is checking inventory? It can't just shout into the void and hope for the best.
And the solution is actually pretty genius. The agent card. The best way to think about it is like a LinkedIn profile or a digital resume, but for an AI. It's just a simple file that lists everything another agent would need to know. Its name, what it does, and, most importantly, its capabilities. So all CustomerBot has to do is find OrderBot's card to know it's the right AI for the job. So once CustomerBot hands off the task, it goes through this really clear, trackable workflow. First, the task is marked as submitted. Then, as OrderBot starts checking the database, the status changes to working. Now, if OrderBot needed more info, like a product number, the status would flip to input required. And finally, the task is either marked completed with the answer or failed if something went sideways. It gives you a perfect real-time view of what's happening.
And here's the kicker. When the job's done, the result isn't just some random text message. No, it's delivered as a structured artifact. And this is so important because it packages the answer, the inventory status, in a clean, predictable format. That means CustomerBot, or any other agent for that matter, can instantly understand the data and use it without any confusion.
All right, so we've seen how one task gets done. Let's zoom out of it. Because it's not always just a simple handoff, right? How do these interactions create more complex team dynamics?
You can pretty much boil these interactions down to three main types. You've got agents working together cooperatively, agents competing against each other, and agents that negotiate to sort of find a middle ground. So for a cooperative setup, imagine a bunch of agents, one for shipping, one for warehousing, one for manufacturing, all sharing info to make a supply chain run smoother. But then you've got the competitive model, like an online auction. There you'd have agents representing different bidders, all competing to get the best deal. And then, of course, there's negotiation, where a buyer agent and a seller agent might go back and forth on a price.
Now, this is a really important point. You might be hearing about other protocols out there, and it's easy to get them mixed up. A big one people talk about is the Model Context Protocol, or MCP. They might sound kind of similar, but they're built for completely different jobs.
And when you put them side by side, the difference is just crystal clear. Look at A to A. It's from Google.
and its entire focus is on agent-to-agent collaboration, so at helping autonomous AIs work together. Now look at MCP from Anthropic. Its focus is totally different. It's about helping a big AI model use external tools, like pulling data from an API.
So, if you remember one thing, let it be this. A2A is for building a team of autonomous players who can strategize and work together. MCP is about giving a single, powerful player a toolbox. Both are super important, but they solve very, very different problems.
Okay, so what's the big picture here? Why does having a standard language for AIs matter so much? What does this mean for everything?
Well, the advantages are huge. First, because it uses web standards, you get what's called interoperability. It just works, no matter who built the agent. Then there's flexibility. It can handle anything from text to audio to video. And super important for any real-world use, security is baked right in from the start. Plus, it's designed to handle those long, complex jobs with constant updates. These aren't just features. They're the foundation for a whole new way of building intelligence systems.
And you can see this popping up, well, everywhere. We're talking about fleets of autonomous cars coordinating with each other to avoid traffic, smart grids where agents are balancing energy supply and demand every second, or supply chains that run so efficiently it's almost hard to imagine. This isn't just about tweaking old systems, it's about creating brand new ones.
And that leaves us with this one kind of mind-blowing question. We are just at the starting line here. But what happens? What kind of world do we build? When trillions of intelligent agents can find each other, negotiate, and team up to solve problems we can't even properly imagine yet. That's definitely something to think about.